hopefully you've taken some time to look at the solution to this problem that was written in your packet and is shown here. There is one error that happens with the trigonometry here. The angle is labeled correctly, but down here it says that v naught x, which is on this side, which is opposite the 60-degree angle, it says to use cosine, but this should actually be sine. And same thing here, this should be cosine. And so these are reversed. Okay, but that's a relatively minor error. That's it's an important error, but it's not a physics error. It's a really significant math error, but there's a really important physics error that we need to find here. We look, and the wall is 14 meters, and the path the trajectory is shown coming up here right to the top of the wall. We were supposed to figure out whether the cannonball made it over the wall or not. And instead of drawing it right to the top of the wall, we need to realize that it may not get there. And so we need to restate the question. We need to say, is y greater than 14 meters? Because that's what's going to tell us whether it gets over the wall. So that's what we're going to need to find. Okay. Also, is the solution complete? No, because we see that part B wasn't done. So let's go ahead and redo this problem, and you have room in your packet, a fresh problem-solving template on which you can do this. Let's go ahead and fill this in correctly. We've got 67 meters per second sine of 60 degrees, and that is 58 meters per second, actually 58.0. And this is 33.5 meters per second. We're trying to find y, which is going to have units of meters. And it's not just any y, it's y when x equals 25 meters. And then we need a plan for this other part. So this part, y greater than 14 meters, that's our restated question. And then here, and we could say for x equals 25 meters. And then this one, our question can be, is Vy greater than or equal to 0? Or not. I guess I should say greater than. Because if it's greater than 0, then it's on its way up. Okay, so we're also going to find Vy. Okay, so we find y and Vy, both of which are for when x is equal to 25 meters. So our solution can be based on that. X equals x naught plus v naught xt. We don't need to write the rest of it because we know that a sub x is equal to 0. I'll write that up here. And that's going to allow us to solve for the time. In the y direction, we're going to want to use this equation, y equals y naught plus v naught yt plus 1/2 ay t squared. That'll tell us y. And then Vy, we're not going to have to do any algebra here either, because we have a nice equation that will give us v sub y. So we know this, we know this, we know this. We don't know the time, and we know v naught y, we know ay, we don't know the time. Okay, so first find t, and then here, and then here. So there's our plan. We'll go ahead and execute it. 25 meters equals 0 plus 58 meters per second times t. Okay, and we're sticking with our keeping horizontal stuff over on the left, vertical over on the right. So time 0.431 seconds. And then that's all we need. That's all the space we need to analyze the horizontal direction. Now for the vertical direction, we can say y equals 0 plus 33.5 meters per second times 0.431 seconds. Make sure your squared is outside the parentheses. It pertains to the number and the unit. Okay, we get a value of 13.5 meters, which is less than 14 meters. Ball does not clear the wall. And then we can find Vy, which is equal to 33.5 meters per second minus 9.8 meters per second squared times 0.431 seconds. And we get a Vy of 29.3 meters per second. That makes sense. After less than half a second, this cannonball, which was launched pretty quickly, is still going upward. So this is positive Vy. So on its way up. Alright, so now our solution really is complete. Sign of the answer is correct. We got a positive value here. We didn't really know what this was going to come out to be. That was the whole point. The units do work out. If you carefully work through the units, you'll see they work out just fine, and the magnitudes are reasonable. I'd also like to take a moment and talk about the diagram. This diagram was definitely incorrect, and so on your paper, I'd like you to draw a better diagram than what's up here. So here's an example of what the diagram might look like. So here it is, the ball is hitting the wall on the way up. But remember, at the beginning of the problem, you didn't know what the diagram was going to look like. You didn't know if it was going to go over the wall or not. You didn't know if it was going to be on the way up or not. So a really good diagram here would include 4 possibilities. We don't really know the scale. We can label this from here to here as 25 meters. And we can label from here to here as 14. But we don't know what the trajectory is really going to look like compared to the wall. So it could have been that this is what a 14-meter high wall looked like with the ball going up and over it. It could have been that our 14-meter high wall was actually here. It was going to clear the wall, but the ball was going to be coming down by the time it got to the wall. Or the fourth possibility, that the ball doesn't clear the wall, but it's on the way down when it gets to that wall. So all 4 of these were equally good possibilities at the beginning of the problem. And the numbers that are in the problem as far as the initial speed, the height of the wall, the distance away, those could all be easily manipulated so that any of the 4 of these possibilities could be true.